Okay, the purpose of this video is to talk about net integrals or net area versus total area, and then how to do this on a graphing calculator. Okay, so I mean they certainly talk you through it in the book. I will show you, walk you through those two a little bit. So this is some car. I guess it's moving constant velocity of 40, and then it puts it in reverse and a constant velocity of 30 on the reverse. Boy, they're going fast. Oh, I guess it's moving south. I see it. North and south, not in reverse. So what we do is if you're talking about the net distance it's traveled, so it moved north for, let's see, what is that? That's 2 times 40 is 80 kilometers, is it? What's the units here? 40 miles per hour. So they did 80 miles going north. Then they turned around and they went 1 times 30 miles south. So that means their net displacement, they're at, if supposing they started at zero, they're still 50 miles to the north of where they started, right? Now, if we wanted to talk about total distance is we make that negative area positive and we add them together. So they went all together, they went 80 plus 30, 110 miles where they traveled. Okay, so that's pretty easy to do. And to here, they talk about breaking out the interval. See what they do? They break up the integral from where it changes sign. Up here, it's a positive area. Down here, it's a negative area. You got to break it out to two different integrals. And do you see how? Well, actually, we don't have to break it out to two different integrals. What you could do is, well, you'll see when we do. Well, here's the total distance. See how they do that absolute value? What you could do is let's do something that's a little more wonky. Like, what are they going to do it here? Okay, so the net. So what they do when they find the antiderivative, and then they just drop and they're evaluating the fundamental theorem of calculus part 2, right? That's the evaluation, right? Yes. So then you drop in 3, you drop in 0, and that gives you the net change. If you want to find total area or the net displacement, see, and you can see how the negative cancels out the positive, like up above, but just not as nice rectangles. Then you get the total distance traveled. Is you've got to They tell you find where the line crosses, the curve crosses the x-intercept. That's where it goes from a negative to a positive or positive to a negative. And then you set up your two integrals by hand, and you got to make sure. Let's see, what do they do here? I want to make sure that they do it the way I'm thinking about it. What I would do is I would put that negative out in front of the integral because that's that multiple rule, right? So just find the area normal, and then remember you're going to change the sign. Okay, so that's how you do that. Now, while I'm at this, let me show you how to do this in the graphing calculator. So I haven't done this yet. Maybe you found this online. It's important to show the setup. You can't just give the answer, but this certainly can save us some work. It also, if the question is asking you for an exact value, you've got to do it by hand. Okay, so I'll probably ask you that on the exam, sure, because I want to make sure that you can apply the fundamental theorem of calculus. So you'll have to give me an exact value. But what you can do in the calculator as a check, or if it's a multiple choice or a calculated answer question, what you can do is if you do math and then 9, see F in it. And on the newer version, if you have an old TI-83, it doesn't look like this. It looks like, I'll show you what it looks like in a minute. But if I had to evaluate this, let's see, what do they want us to do? Evaluate, we're trying to evaluate, where do they give us the integral? What's the function? I guess they don't give us 3t minus 5, and we want to find the area between 0 and 3, is it? Yeah, 0 to 3. So I'm going to do 0 my lower bound. Can't use my mouse. I got to 3 is my upper bound, and then I'm going to type in the 3x minus 5. Then of course you got to say, what are you taking the integral with respect to? That's x. Then press enter, and notice we're getting the -3/2 like we did. So that's the net area. Now, if you want to find the total distance traveled, remember how we were taking the absolute value, taking the oh, they show you the absolute value in the book, but you know how we got to take the negative area and make it positive? What happens when we take the absolute value of a positive number? I say, well, man, it just stays positive. You're right. So what we do is this. We're going to do, you can, let me do math 9 again. So math 9, and then I go from 0 to 3 again. But here's what you do that's a little different. You're gonna put an absolute value sign in there. So math, if you come over to numbers and type a 1, now you can type in the function 3x minus 5 dx. What that's going to do is it's going to take all the negative areas, make them positive, and all the positive areas stay positive. And you're going to see in a minute that that's the answer. Now let's make sure that that agrees with the textbook. Let's see for the total here. Total distance, blah, 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 blah. So they're saying 41 over 6. That's 41 divided by 6. I'm hoping what the calculator said. 6.833. I think that's what the calculator said. Come on, open up, open up. I'm going to drag down. 6.833. Yes. So, okay, so that's how you can use f and int to evaluate a definite integral. If you were a high school student getting ready to take the AP test, on the AP test on a calculator active question, you can use f and int to evaluate a definite integral. If it's not a calculator active, then you need to do it by hand. So I'm going to treat you guys the same way because I think that's a great test. It measures things really well. Yeah, so that's how you do that. So absolute value inside absolute value of the function. The other thing you can do is if you got a really wonky equation and you don't want to have to here, let me clear out. I was doing some work earlier. Let me clear this out. Let me pause this video and we'll take a look at the book and get a wonky equation. Okay, so here's a wonky equation, one that you do not have the skills yet to integrate, and you're not going to in this course. That's a Calc 2, needs integration by parts. And so we aren't going to do that. We just don't have time to do it. So you're off the hook for this semester. It's not hard. It's not a hard process. So we've got this graph. So I'm thinking this is a vertical asymptote. This ln function has a vertical asymptote at x equals 1 because I can't take the ln of 0, right? So if I graph it, you see how it kind of stops there. And if I tried to hit trace, it would give me no answer at x equals 1, right? So let's say I wanted to find the integral from 1.2 until here. Let me get a pointer going here. Actually, maybe I won't get a pointer going. Maybe I'll just write it. Let's say I'm trying to integrate this. I'm going to find the total distance traveled. Say or the total area from 1.2 until 2. Oh, but let's go through. Okay, x ln x minus 1, right? Yes. So I got to find that area. So what I'm doing is basically I'm coming close to 1, but not quite there. And then that's a red area because that's negative, right? And then we're going to go to 2. I said, or I'm going to go to 3. 1, 1, 2, 3. Oh, it's a good thing I went thinking 3 over from there. That's okay. This will work. And that's a positive area. So net area would cancel it out. Cancel out the positive and the negatives. Looking quickly at this. It looks like the red negative is bigger than the green positive, but I don't know. So let's find the net area and let's find the total area. I'm going to show you a different way to do this. Now, see, I already have this. Instead of doing what I showed you with hitting math 9, see if I hit math 9. I mean, I can certainly type it in here. That's not wrong. But I've already got this equation into y1. So why do more work than I need to? And I don't know if you've ever done this. I mean, if you're new to this graphing calculator, it's been a while. This might be new for you. Let's see, I want to do, there we go. I want to go from 0 No, not 0. I want to go from 1.2. I wrote it right up there. That's one nice thing. Up to 3. And then instead of having to type in that equation, I've got it in Y1. See the bars button here? Let me get a pointer so you can see where I'm pointing. That bars button, actually, if I clear my keypad presses, you might be able to see this better. Okay. So if I press bars and then arrow over to Y bars and then type a 1 for the function, and it's in function 1 in Y1. So I'm just going to type, you can hit enter, or I'm just going to type a 1. And see, there it dumps that equation into the integral, and we're going to do x, and then enter, and that's the net area. So I was wrong. It looks like it was the green area was bigger than the positive area is bigger than the negative area. But now, so that's the net area. And if I wanted to do the total area, what would I have to do? Thought, oh yeah, I got to do the absolute value of that. So I'm going to be really lazy. Second enter, and then I'm going to stick. Just go back to the inside, and I'm going to do math num 1. And then I got to do the bars, y bars, bars, y bars. And this will tell me the total area. And notice it is quite a bit bigger. Okay, so it's a wonderful thing. You're going to really like it. Just don't become too reliant on it. You want to be able to, to do this, you got to break this, you got to break, if I graph this, I've got to break it out to positive and negative. If I had to do this one by hand, which you can't do through the LN, I would have to find that intersection. I'm guessing probably 2. I don't know. A couple of ways to do that with the calculator. Second calc, 0. And then you can do left. You can do left bound. Why don't we do left bound of 1.5? You can do the right bound of 3. And just guess, let it guess. And so it does cross it too. So to do this by hand, would have to do the integral from 1.2 to 2 of that x, ln x minus 1 dx. That's a negative area, so we got to make it negative. Okay, and we calculate it, and it'll be a positive number, and that'll make it negative. And then plus we need to do the integral from 2 until 3 of x ln x minus 1 dx. Okay, so that's the big thinking that I'm going to ask you to do. I might show this like a multiple choice question where I break out the integrals and gonna know what you're doing, but it's not hard. Okay, so hopefully that helps. Math 9.